Swayam Prabha. Digital India. Educated India.
What is the point group? And where is my character table? Now I am at a loss. I'd better not lose that character table. Huh? What is this? Don't tell me I did this. Oh man. Well, it just means that you have to spend a few minutes in copying the thing. And me too. Okay, benzene. Anyway. So what we'll need is the D6H character table. And right now I have no option but to write it. I want to talk about pi bonding of benzene. What is my basis? The 6 p orbitals, 1 on each carbon, right? So what will be the dimensionality of the representation that I get? 6, right? Now when I break that down, I'll just give you that answer. This is D6H. Gamma pi turns out to be A2U plus B2G plus E1G plus E2U. I strongly recommend that you work this out yourself, okay, it will be good practice. Now what I want to do of course is that I do not want to work with D6H, it is too big. What is the subgroup that I want to use? C6. So that will be a smaller character table, I can write it. C6. What do we have in C6? We have E, C6, C6 square is C3, then C3 square, well the way it is written is C2. What is C2? How do I get C2? C6 cube, right? C6 cube is C2, then C3 square and finally C6 to the power 5. So C6 to the power 1, C6 to the power 2, C6 to the power 3, C6 to the power 4, C6 to the power 5, C6 to the power 6, right? So A is 1 1 1 1 1 1. Then you have E1, which is a combination of 1 epsilon, epsilon square star. What am I doing? 1 epsilon minus epsilon star. This is minus 1, this is why I did not want to do this, minus epsilon star, and this is 1 epsilon star minus epsilon. What is the relationship between epsilon and epsilon star other than the fact that they are conjugates? they add up to give -1. You just worked it out. 1 epsilon star minus epsilon, -1 minus epsilon star epsilon, okay, and then you have E2 write like this, minus epsilon star minus epsilon minus epsilon minus epsilon star 1 1 minus epsilon star minus epsilon minus epsilon minus epsilon star. Okay. So, what is gamma phi in C6? What will gamma phi be in C6? See, that is why I needed the character table. Anyway, please work out the correlation yourself. You need to have the two character tables in front of yourself. Just believe me when I write this, A plus B plus E1 plus E2. What do you mean B is not there? That's because I have not written it. One minus one, this is 1 minus 1. But you should have noticed that something is missing, right? Because only 5 were there, there has to be 6. So 1 minus 1, 1 minus 1, 1 minus 1. Not very difficult to remember. 1 minus 1, 1 minus 1, 1 minus 1. Okay, let me just turn the page. This is very confusing for me. So many ones and so many epsilons. Fine. Okay, now what should I do? First thing, let us recall what we said for that 3 atom system, 3 phi system. What is the only role of these C3 operations? Okay, what happens when C6 operation here? C6 operates on phi 1, what will you get? Phi 2. C6 square on phi 1, phi 3. C6 cube, C6 to the power 4. C6 to the power 5 and C6 to the power 6. So, it does not matter which projection operator I use, I can write it like this. Any projection operator operating on phi 1 should give me something like this, chi e into phi 1 plus chi C6 into phi 2 plus chi, why not? C6 means one rotation, right? One rotation by what? 360 degrees by 6, that is 60 degrees. One rotation by 60 degrees should take me from phi 1 to phi 2, right or wrong? This is C6, you rotate once, you go from 1 to 2, rotate twice, go from 1 to 3, rotate thrice, go from 1 to 4, rotate 4 times, go to 5, rotate 5 times, go to 6, rotate 6 times, come back to 1. Shubhangi, is this okay? Are you all okay with this? So, chi e into phi 1 plus chi C6 into phi 2 plus chi C3 into phi 3 plus chi C2 into phi 4 plus chi C3 square into phi 5 plus chi C6 to the power 5 into phi 6. Okay. So, once again what we have generated is a linear combination of atomic orbitals that is going to happen for cyclic systems. Okay. I hope you have taken down the character table. Huh? So, may I go to a fresh page? I myself do not like the sight of this ugly character table that I have written. All right. So, if you do that, what do you get? Work out the 6, what is it called? SALCs that you get this way. What will be the symmetries? A, B, then for E1 you will get 2, for E2 you will get 2. So, A, B, E1 you should get 2 and for E2 also you should get 2. What do you get? A even I will write. That is very easy, right? Especially since you have written that chi E into phi 1 plus chi C6 into phi 2 and so on and so forth. A is very easy, all chi's are 1, right? So, that is what it is. What about B? That is also easy, just have to multiply by chi's now. What will it be? Phi 1 minus phi 2, then plus phi 3 minus phi 4, then plus phi 5 minus phi 6. Even before writing the other two, I want to see if I can draw the nodes. Okay. So, this is for A, this is for B. So, here everything is possible, everything is positive rather, everything is positive. So, how many nodes for A? 0. And what about this? Phi 1 is plus, phi 2 is minus, phi 3 is plus, phi 4 is minus, phi 5 is plus, phi 6 is minus. So, it is full of nodes. How will I draw the nodes? So, this is one node, this is one node, this is another node. 3 nodes, isn't it? So, does that remind you of the pi orbitals of benzene or not? You have drawn it in some way or the other, right? So, this is the lowest energy pi orbital of benzene. This is actually the highest energy pi orbital of benzene. No node and 3 nodes, isn't it? So, what will be the normalization constant? Both cases? Now, what about E1? What are the two? What is psi 3? Remember, you just have to multiply by the corresponding characters. Phi 1, phi 2, phi 3, phi 4, phi 5, phi 6 are there. You just have to multiply by the corresponding characters. It is not difficult. 2 phi 1? No, I am taking them separately, right? These are one dimensional IRs. What am I, which group am I working with? Am I working with D6H? No. I am working with C6, right? So if I can get back to my ugly character table, that's later. First you use the IRs. Okay. See, this is one IR, this is one IR. It is just that we have combined them and given the name like that. But you must work with the individual IRs. Okay. So first you are going to generate the complex LCAOs. Okay. And then from there we are going to generate the real ones. So now tell me, what is psi 3? Phi 1 plus epsilon phi 2 minus epsilon star phi 3 minus phi 4, very good, epsilon phi 5 minus or plus? Plus E1, no? Wait, I think it is my mistake translated to you. Hold on, let me check. I think it's plus. Yeah. Plus, these are plus. That's why I took the printout. Plus epsilon star phi 6. And what about psi 4? Phi 1 plus epsilon star phi 2 minus epsilon phi 3 minus phi 4 minus epsilon star phi 5 plus epsilon phi 6. Okay. So, I have generated the SLCs. What is the next step? Add and subtract. See, what we will do is, we will worry about E2 later in the next page maybe. Let us worry about this first. Add and subtract, what do you get? What do you get when you add? Hold on. 251 plus phi 2, right? Don't tell me there is another mistake somewhere. Okay, what have you got? 251 minus phi 2, then? Okay, then? For some reason all your plus minuses are interchanged. I don't know why, yeah. What? It is 2 pi I by 6. That is why. It's 2 pi I by 6. Remember, we had discussed that once. 2 pi I by 6, that's why you are getting a different result. Okay, so I will spare you the trouble and write the answer. 2 phi 1 plus phi 2 minus phi 3 minus 2 phi 4 minus phi 5 plus phi 6. What is the normalization constant? 1 by, okay, what is this? 1 by 2 root 3 will be common. Now can you work out when you subtract and divide by I, what you get? Minus 5 to minus 5 3, then plus 5 5 plus 5 6, that is right. It is just that I am justified in writing the minus 1 also. If you write that, you are fine, there is no problem. But generally we like to, actually it is not 1 by root 2, what am I doing? I write it like 5 2 plus 5 3 minus 5 5 minus 5 6. Normalization constant? 1 by 2. So now let me, you have this written down in your notebook anyway, right? So let me just draw the diagram once again. Maybe I can write the others here. So first you have A. Should I call it A? When I go back to D6H, what will it become? It's not A anymore, right? What is it in D6H? D6H, what is it? A1G, isn't it? A1G, is it A1G? I don't have A1G. What was the, what are the symmetries that we got from D6H? A2U plus B2G plus E1G plus E2U, right? So this is A2U. See, this is what I told you, isn't it? That in D6H, gamma pi is A2U plus B2G plus E1G plus E2U. Then we went from D6H to C6. Then we said that by that correlation diagram, A2U becomes A, B2G becomes B, E1G becomes E1, E2U becomes E2, right? Now jumping steps here, but you can work it out yourself, you can work out the correlation diagram. Okay. So now what we did is, after that, we worked out what is the linear combination of asymmetry, okay, and that is just plus 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 plus. Now, yes. Which one?
In the next slide. 1 by 2, 3 and 1.
Wait, we'll come to that. Let us first finish this. So, if it is A in C6, which symmetry species is it in D6H? Has to be A2U, right? But we don't have A1G or anything. The only A kind of symmetry species we have is A2U, right? So, it's A2U. So, instead of writing it as A, if I go back to the full group, I should write it as A2U. What is A2U? No node. Okay. What is the next one that we have worked out? B. So, B is what? B2U. B2U or G? B2G. We will come back to that later. Now, let me answer that question. So, you are asking how I got 1 by 2 root 3. What did you get? I am trying to normalize, right? See, to normalize, what do I have to do? I have to multiply it by itself and get 1, right. So, what do I get? 4 plus 1 plus 1 plus 2 plus 4, sorry, plus 1 plus 1. What is that? Hey, don't talk. 12, right. So, then it becomes 1 by square root of 12. So, 4 in any case you can get square root. So, 2 comes out and you are left with 1 by 2 root 3. The answer given in contents book is 1 by root 12, but 1 by 2 root 3 is fine. Yeah. You just neglect that because you have to finally normalize. Whatever coefficient comes out is of no consequence because eventually you have to normalize. Okay. So, just neglect all coefficients, whatever comes out common just throw, work with only the sum and then find the coefficient from the condition of normalization. Okay. Fine. So, now next tell me where was I writing? E1. So, E1A, what is the point group, what is the symmetry species in D6H? E1G, right. So, let us write it as E1G and then what will I write? Let me write A here. What is the expression? Two phi 1. So, this is plus phi 2 plus phi 2 minus phi 3 minus 2 phi 4 minus plus how many nodes? And these orbitals are bigger than this. Sometimes you see that diagram also, right? The orbitals are drawn bigger, one is big, one is small, this is what it means. Got it? So, what is your E1G B? Phi 2 plus phi 3 minus phi 5 minus phi 6, right? Did you work that out or not? Phi 2 plus phi 3, nothing in phi 4, minus phi 5 minus phi 6. How many nodes? Where is it? That is a node, not this, right? This is not a node because this is plus, this is minus. Wave function is not changing sign. Wave function is changing sign from here to here, right, from left to right. So, one node here, one node there, should they not be degenerate, right? So, what is the symmetry species they belong to? E1G, which is a two-dimensional symmetry species. So, see, this is another manifestation that degeneracy and symmetry go hand in hand. If the orbitals belong to a two-dimensional symmetry species, then they are going to be doubly degenerate. If they belong to a three-dimensional symmetry species, then they are going to be triply degenerate. Okay? Now, what is left? E2. And now we have pros. So, can we work out E2 quickly? Psi 5, what is psi 5? Work in the C6 point group and get me the complex wave function. What is psi 5? Phi 1 epsilon star phi 2 minus epsilon phi 3 plus phi 4 minus epsilon star phi 5 minus epsilon phi 6. And what is psi 6?
phi 1
Phi 1
minus epsilon phi 2 minus epsilon star phi 3 plus phi 4 minus epsilon phi 5 minus epsilon star phi 6.
Add and subtract, what do you get? However written it. So when I add and subtract, what should I get? E to U A is equal to what? 2 phi 1 minus phi 2 minus phi 3 plus 2 phi 4 minus phi 5 minus phi 6. Very good. Coefficient? I mean constant 1 by root 12 or 2 root 3, whatever you want to write, but definitely not 1 by root 2. What is your E to U B? Phi 2 minus phi 3 plus phi 5 minus phi 6. Normalization constant? 1 by 2, 1 by root 4. So 2 phi 1, big black circle, minus phi 2, small hollow circle, minus phi 3, hollow circle, plus 2 phi 4, minus phi 5, minus phi 6. Let us finish this one also. Phi 2 minus phi 3, phi 2 minus phi 3 plus phi 5 minus phi 6. Do you see the nodes? This is a node, this is a node, and here this is a node, this is a node. Okay? Okay, and let me just draw the last one also. What is it that we had worked out already? What is the symmetry point group? Sorry, what is the symmetry species in D6H point group? B2G. Tell me what it is. Phi 1, phi 2. Phi 1 minus phi 2 plus phi 3 minus phi 4 minus phi 6. How many nodes? 1, 2, 3. So see, just by going by the number of nodes, we can say that the energy levels of benzene would be like this. This is something that you know already, right? These three are bonding orbitals, those three are anti-bonding orbitals. How many electrons are there? How many pi electrons? So this is how we generally fill in a simple manner. But what we have learned now is that now we can write the labels, right, for the orbitals. This is A2U, this is E1G, this is E2U, this is B2G. How to get the symmetries of states or how to get the nomenclature of states comes after this.